Southfield, Michigan. The police are still investigating.
Man, it's not even no mail today. Oh shit.
A local resident, Frederick John, was there to take the whole thing. Frederick, please tell me your thoughts on the whole situation.
World Star!
Okay, so we're here with Frederick John.
I go by Fred, though. Come on, I'm the legal name out there.
Okay. Well, so what did you see?
And I was out there, I was checking the mailbox. I seen two cars go by. I was on Instagram and I was going there. Seen it and I had to get it.
Okay, so how did you get it?
I mean, like I said, I was on Instagram, you know, I was on Instagram and down light and I'm going in there and I see him, so I whipped out the phone. I didn't know how I did it because they was going fast, but I tried to get it, man. Hey, where you gonna pick up? Come on, man, get out.
A $1 million reward for anyone who can figure out how fast Frederick's camera was moving.
Okay, so the camera is located 50 feet from the straight road along which a car is traveling at 100 feet per second. The camera turns so that it's pointing at the car at all times. In ratings per second, how fast is the camera turning as the car passes closer to the camera? So, when solving the problem, we should start by trying to get a visual idea of what's going on. And the best way to illustrate the scenario is to represent the situation with a right triangle in which the base leg consists of a straight road. The other leg is formed from the 50-foot distance between the road and the camera, and the distance between the camera and the car creates the hypotenuse. In our situation, theta is the angle created from the 50-foot leg and the hypotenuse, and the distance between the car and the intersection of the legs is some value x. We are given the speed of the car, in other words, the rate at which x is changing, to be negative 100 feet per second. Negative because the distance between the car and the intersection is decreasing. Since we want to find the rate at which the camera is turning, in other words, d theta dt, when theta is 0, symbolizing the car passing closer to the camera, we have to find a formula or equation that relates the two variables x and theta. Given the circumstances, tangent of theta is one of the best equations to use since it relates opposite side x, the adjacent side 50 feet, and the angle theta, thus giving us the equation tangent of theta equals x over 50 feet. Now that we have our equation, we must find the derivative of it in regards to time so that we can incorporate the rates to solve for d theta dt. With that said, the derivative of tangent of theta equals x over 50 feet. With respect to time, is secant squared theta times d theta dt equals 1 over 50 feet times dx dt. Since we are solving for d theta dt, we have to isolate it on one side by dividing both sides of the equation by secant squared theta, leaving us with d theta over dt equals 1 over 50 feet times dx dt all over secant squared theta. From this point, we plug in the information we're given and set theta equal to 0. Thus giving us d theta dt equals 1 over 50 feet times 100 feet per second all over secant squared to 0. The top simplifies to negative 2 and the bottom secant squared to 0 is just 1. So as the car is passing closer to the road, the camera is turning at negative 2 radians per second.